Hi dears, we are going to start our first chapter, electric charges and field. Let me ask one question. When you travel by bus or car, slides from your seat and touch the iron rod in the bus, we may feel a shock. What is the reason for this? You are traveling in a bus, you are sliding from your seat, after that you are touching a rod. Then you may feel a shock. What is the reason? That's my question. When we slide from our seat, a charge is created or charge is generated on us. Okay, after that, when we are touch iron rod, it gets discharged through our body. It gets discharged through our body, thus we feel a shock. When we slide over the seat, a charge is generated on our body. When we touch the iron rod, this charge is discharged. Thus we feel a shock. You may have doubt how a charge is generated when we slide over the seat. What is the reason for that? So we will explain all the things in this chapter. And also, if we do not touch the iron rod, so after sliding, a charge is created on our body. But if you do not touch the iron rod, we will not feel a shock and the charge on us still there. Okay, so we are in this chapter, we are discussing about static charges. So what are static charges? Charges do not move their own. Charges do not move their own. That is why they are called static charges. They are called static charges. Okay, they do not move by their own. And the branch of physics which deals with the study of static charges, the branch of physics which deals with the study of static charges and effect produced by them is called electrostatics. So what do you mean by electrostatics? It's a branch of physics that deals with the study of charges at rest, that means static charges. Okay, so that is called electrostatics. In our syllabus, the first two chapters, the first chapter the charges and fields, and the second chapter electrostatic potential and capacitance. These two chapters come under electrostatics, that means charges at rest. Then another term is electrodynamics, so charges in motion. So magnetic fields also exist there, so that we will discuss later. So now we are discussing about static charges, that means electrostatics. So to discuss electrostatics, you have to know what you mean by an electric charge. A Greek mathematician, Thales of Miletus, he rubbed amber with wool or silk. He rubbed amber with wool or silk, which attract light objects. After rubbing, that attracts lighter objects. So what is the reason? Before many years ago, he observed that when amber is rubbed with wool or cloth, it attracts lighter objects. The word electricity is derived from the Greek word electron, which means amber. Why it is called so? When amber is rubbed with silk, it attracts the light objects. So that term, the word electricity, is derived from the Greek word electron, which means amber. Okay, then there are such many substances which can be charged by rubbing. One example is balloon and hair. If you rub balloon and hair, the bodies will get a charge. And also comb charged from hair attracts paper. When you rub the comb on your hair, that comb attracts paper. And also glass rod and silk. If you rub glass rod and silk, the bodies will get charged. What are the reason for this? So we have observed that when one body is rubbed with another object, the bodies get charged. What is the reason? So the reason is a body can be charged by positively by losing some electrons and can be charged negatively by gaining some electrons. So when you rub an object with another object, there will be transfer of electrons. What is that? There will be transfer of electrons. When you rub an object with another object, there will be a transfer of electrons. Electrons will be transferred from one object to another object. The object which gains electron will get negative charge. What is that? Negative charge. The object which gets electron, which gain electrons will get negative charge. And the objects which loses electron will get positive charge. What is that? Positive charge. The objects which gain electrons will get negative charge, and the object which loses electron will get positive charge. So that is why the objects are charged due to rubbing. Okay, let us consider some examples. Take two pith balls hanging from a string. We are taking two pith balls which are hanging from a string. Take two pith balls which are hanging from a string. A glass rod rubbed with silk. Rubbing glass rod with silk. Glass rod with silk. Glass rod with silk. Then plastic rod with fur. Next, plastic rod with fur. So take the two pith balls hanging from a string, also a glass rod rubbed with silk, and a plastic rod rubbed with fur. When these objects rub, what happens? They may get charged. Okay. Then so these are two pith balls. When glass rod rubbed with silk, silk gain electrons from glass rod. Then the glass rod get positive charge and the silk get negative charge. The glass rod gets positive charge and the silk gets negative charge because the silk gain electrons from glass rod. That means glass rod loses electron. In the same way, when plastic rod rubbed with fur, plastic rod gain electrons from fur. That means the plastic rod get negative charge and the fur get positive charge. When glass rod rubbed with silk, glass rod will be positively charged and the silk will be negatively charged. When plastic rod is rubbed with fur, the plastic rod is negatively charged and the fur get positively charged because the silk and plastic rod gain electrons, and for glass rod and fur the electron loses. So they get positive charge and those who gain electrons will get negative charge. Then what is the next step? What happens when ball is touched with the plastic rod and another ball is touched with the glass rod? One ball is touched with the plastic rod and this will get negative charge. When we touch with this, we will get negative charge. Then another ball is touched with the glass rod. Another one it is with the glass rod. It is positively charged. So we are touching plastic rod with one ball and glass rod with another ball. What happens? So one is negatively charged and other one is positively charged. Then what happens? They attract each other. They attract each other. So like this, they attract each other because one is positively charged and another one is negatively charged. So we can say that from this we can say that the unlike charges attract each other. One is negative, other one is positive. So that the unlike charges attract each other. Okay, then what is next? What happens when both the pith balls are touched with the plastic rod? So listen, you are touching both the pith balls with the plastic rods. What happens? This will get a positively charged and this also will get a positive charge because we are touched with a glass rod. Okay, when we touch with the glass rod, this will get positive charge and this will get a negative charge. When we touch with the plastic rod, both of them will get negative charge. Both of the balls will get a negative charge. Then what happens? These are like charges. So it is observed that these charges repel each other. This is positive and this is also positive because both are touched with a glass rod. What happens here? They also repel each other. Why? One is touched with a glass rod, sorry, a plastic rod, and this one is also rubbed with a plastic rod. So the both will get negative charge. Then they repel. Then it means that unlike charges, the like charges repel and unlike charges attract. So here these two charges attract each other because they are unlike charges. One is positive and other one is negative. What about here? They repel each other. Why? One is positive charge and other one it is a negative charge. So we can say that the like charges repel and unlike charges attract each other. Like charges repel and unlike charges attract each other. Next, there is one device called gold leaf electroscope. So what is the use of gold leaf electroscope? It is used to detect the charge on a body. Electroscope is a device used to detect charge on a body. Electroscope is a device used to detect charge on a body. Okay, then how we find a body is charged or not? Listen, we are placing a charged body on the top of the metallic disc. So this is a metallic disc. So touch the body, charged body with this metallic disc. Then what happens? This charge passes through this, okay, this rod and it reaches at this gold leaf. Both the gold leaf will get a positive charge. Both the gold leaf will get a positive charge. So there is a metallic disc, then there is a metallic rod, then at the end of this metallic rod, two gold leaves are there. Then when we touch the object or charged object with this disc, what happens? This charge flows and reaches at gold leaf. There are two leaves for gold leaf. What happens? Both are positively charged. They diverge. It means that the body is charged. If there is no charge on the body, the gold leaf will not diverge. If there is no charge on the body, the gold leaf will not diverge. So from this, you can understand that the gold leaf electroscope is a device used to detect charge on a body. Then when the metal terminal is touched with a charged object, this is the metal terminal or this is the metallic disc. When it is touched with a charged object, what happens? The charge received on gold leaf is same type. When we touch with positive charge, if it is a positive charge, both the leaves will get positive charge and they repel each other. Okay, when it is a negative charge, both the leaves will get negative charge. That means the gold leaf is same type. The charge received on gold leaf is same type and spread apart, proving that the body is charged. So they spread apart means they diverge. When the divergence is more, When the divergence is more, the charge is more stronger. So that means charge flows onto the leaf and they diverge. The degree of divergence is an indicator of amount of charge. Degree of divergence is an amount of or indicator of the amount of charge. Okay, when the divergence is more, the amount of charge is more. Next, let us discuss about conductors and insulators. You all are familiar with conductors and insulators. Here, connect a copper wire between the negatively charged plastic rod and pith ball. We know that when we rub a plastic rod with fur, the fur get positively charged and the plastic rod will get negatively charged. Okay, so we are connecting this negatively charged plastic rod with a pith ball by using a copper wire. So you just connect, this is a plastic rod. So it's a plastic rod. We are connecting this, sorry, it's a negatively charged one, negatively charged plastic rod. We are connecting this negatively charged plastic rod with a pith ball by using a copper wire. Then what happens? This pith ball gets charged. This pith ball gets charged because this copper wire allows the flow of electric charge through it. Then substances which allow transfer of electricity, that means transfer of charges through them, are called conductors. For example, human body is a good conductor, metals are good conductor, and electricity is also a earth is also a good conductor of electricity. Okay, then instead of this copper wire, I am using a nylon wire. Okay, instead of this copper wire, I am using a nylon wire. Then what happens? This body does not get charged. What is the reason for that? The nylon wire does not allow the flow of electric charge through it. Such substances are called insulators. So we can say that substances which do not allow transfer of electricity through them are called insulators. The substances which do not allow transfer of electricity through them are called insulators. You know that, both conductors and insulators. So give examples. Plastic is an example for insulator, nylon is an example for insulator, wood is an example for insulator. Okay, so conductors and insulators. And also keep in your mind, when some charge is transferred to the conductor, it gets spread over the entire surface of the conductor. When a conductor gets charged, it spreads over the entire surface of the conductor. But in the case of insulators, the charge stay at the same place. It stay at the same place. But in the case of a conductor, it is spread over the entire surface of the conductor. In the case of a conductor, the charges spread over the entire surface of the conductor, but in the case of an insulator, it stay at the same place. Okay, so conductors and insulators. One is allow the flow of charges through it. The insulators does not allow the flow of charge through it. Okay, so next it is grounding or earthing. You all are familiar with the word grounding or earthing. Okay, so when a charged body touches the earth, what happens? Its charge goes into the earth, producing current. This process of flow of charge to the earth is called grounding or earthing. What is that? Process of flow of charge to the earth is called grounding or earthing. We know that in our household wiring, there are three wires. Which are they? One is live wire, and other one is neutral wire, and then it is earth wire. Which is the color of live wire? It is red in color. Which is the color of neutral wire? It is blue in color. And which is the color of earth wire? It is green in color. It is green in color. So we are familiar with that colors, that wires. Okay, one is in red color, that is live wire. Then other one is blue color, that is neutral wire. And other one is in green color, that is earth wire. Then my question, what is the use of this earth wire in electrical appliances? So we know that the metallic bodies of the electrical appliances, what is that? The metallic body of the electrical appliances, metallic bodies of the electrical appliances such as electric iron, refrigerator, etc. are connected to the earth wire. So which part of the device is connected to earth wire? The metallic part of the device is connected to earth wire. So what is the reason? What is the advantages of that? When any fault occurs or live wire touches the metallic body, live wire touches the metallic body, the charge flows to the earth without damaging the appliances. So it is to protect the electrical devices. When the live wire come into touch with the metallic body, what happens? That metallic body transfers the charge to the earth because this metallic part of the body is connected with the earth wire. So through that earth wire, charges flows to the earth. So this is the purpose of earthing or grounding. So it is to protect the electrical devices. If there is an excess of charge, it may passes to the earth through earth wire. Okay. Next it is charging by contact. When we touch a charged plastic rod with an uncharged pith ball, what happens? Charge transfer from plastic rod to pith ball. That means by touching, charge is transferred from one body to another. So that is called charging by contact. The sum of the negative charges from this plastic rod, because plastic rod is negatively charged, so when we touch it, some of the negative charges transferred to the pith ball and it gets charged. Okay, so this is the method of charging by contact. Listen, there are two identical spheres. Consider two identical spheres, both having same radius, both having same radius. The charge on the first sphere can be taken as QA and the charge on the second sphere can be taken as QB. When we touch these two spheres, what happens? The charge will be transferred from one to another. After touching, what is the charge on the new body? That is given by QA plus QB by 2. So what is that? QA is the charge on the first body, QB is the charge on the second body divided by 2. Okay, that is the charge on the first body. What is the charge on the second body? The charge on the second body is given by QA plus QB by 2. So that is Q dash A is equal to QA plus QB by 2 if they are identical. Then if two spheres are not identical, if two spheres are not identical, then listen, consider two spheres. One is having radius R1 and other one is of having radius R2, or we can take it as RA and RB. So this is the first body and this is the second body. So after touching, before touching, the charge on body is QA and the charge on this body can be taken as QB. Then after touching, what is the charge on QA? What is the charge on QA? QA dash. So that means the charge on the body A after touching can be written like this. That is RA divided by RA plus RB. What is that? RA divided by RA plus RB into QA plus QB. So what is QA? Charge on the first body before touching. What is QB charge on the second body before touching, that is RA by RA plus RB into QA plus QB. Okay, then what is the charge on the second body? The charge on the second body is given by QB dash is equal to RB divided by RA plus RB into QA plus QB. So that is the charge on the second body. So charge on the first body is given by RA plus B into QA plus QB. Charge on the second body is given by RB by RA plus RB into QA plus QB. Let us take one example. When there are two charges having radius, two spheres having radius 2 centimeter and this one is also 2 centimeter. So this one is having 3 microcoulomb and this one is having 5 microcoulomb. After touching, what is the charge on A and B? So this is the body, this is A and this one is B. So what is the charge on A after touching? That can be taken as QA is equal to QA, it is QA plus QB by 2, that is 3 plus minus 2. 3 plus minus 5 by 2, that's equal to minus 2 by 2 is equal to minus 1 microcoulomb. Charge on body A can be taken as minus 1 microcoulomb. What is the charge on B? That is charge on B is equal to two charges, one is 3 microcoulomb, that is 3 plus minus 5 by 2 is equal to minus 2 by 2 is equal to minus 1 microcoulomb. So they are identical charges. Consider there are two spheres. One is having 5 centimeter, having radius 5 centimeter and second one is having radius 10 centimeter. Second one is having radius 10 centimeter. Okay, one is of 5 centimeter and other one is of 10 centimeter. Then the charge on the first body is given by 3 microcoulomb and the charge on the second body is given by 5 microcoulomb. So after touching, what is the charge on the first body and what is the charge on the second body? So after touching, the charge on the first body can be taken as RA by, what is RA? Radius of the first body, that is RA, that is 5 divided by 5 plus 10, RA plus RB into QA plus QB. What is QA? That is 3 microcoulomb, that is 3 plus 5. So that is equal to 5 by 15, that can be taken as 1 by 3 into 8. So what is that? It is equal to 8 by 3 microcoulomb. So charge on the body can be taken as 8 by 3 microcoulomb. So what is the charge on the second body? That is QB dash is equal to the radius of the second sphere is 10 centimeter, that is RB. So we can write like this, 10 divided by 5 plus 10 into QA plus QB. What is QA? QA is 3 microcoulomb, QB is 5 microcoulomb. So that is 3 plus 5 is equal to 8 microcoulomb. That can be written as 2 by 3 into 8. That is equal to 16 by 3 microcoulomb. So what is that? That is equal to 16 by 3 microcoulomb. So charge on the body is 8 by 3 microcoulomb and the charge on B is 16 by 3 microcoulomb. If they are identical, the charge on the both body after touching will be same. If they are not identical, the charge on the body after touching will not be same. Okay, so we are discussing charging by contact. Next, here, is it possible to charge body without touching it? So without touching, we have to charge a body. So is it possible? Let us check it. There is one method, that is charging by induction. So let us discuss what we mean by charging by induction. That is, first step, take two metal spheres initially uncharged. So I am taking two metal spheres initially uncharged. So I am taking two metal spheres initially uncharged. Okay, and touching each other. Okay, and they are touching each other. These two spheres are touching each other. Then what is next step? Bring a positively charged plastic rod near to one sphere. So there are two uncharged spheres. Okay, so we are placing positively charged plastic rod. I am just placing a positively charged plastic rod. What is that? Positively charged plastic rod near to it. What happens? In this sphere, there are negative charges and positive charges. The negative charges will move to this side, left side, and the positive charges will move to this side. Why? The negative charges are attracted by this rod. It is not touching, but it is placing near to it. So these negative charges are attracted by this positive charge. And what happens to this positive charge? These positive charges are repelled by this positive charge. Okay, we can say that free electrons from the metal spheres, comes to the left side. So this is comes to the left side. Okay, then making it negatively charged, and right surface positively charged. Here this is the right surface, it will become positively charged. Okay. Then what is step 3? Separate the spheres by a small distance. Two spheres are found to be oppositely charged and attract each other. So what is that? So this is one sphere. It is gets negatively charged, and this will get positively charged. So rod is here it is positively charged. So after the second step, just separate these two balls. Then what happens? This will get positively charged and this will get negatively charged. Then what is the next step? Remove the rod and separate the spheres quite apart. So remove the rod and separate the spheres apart. So this will get negatively charged and this will get positively charged. Okay, so this process of charging metal spheres is called charging by induction. Here the object is not touched by another object. We are just placing near to the object. We are not touching. So this process of charging a body without touching, that is called charging by induction. First one is charging by contact. We are before we have already discussed about charging by rubbing two objects. Then charging by contact. Then next it is charging by induction. Charging by induction, the both bodies will not touch each other. So without touching, the body is charged. So that is charging by induction. Okay. Next, let us discuss basic properties of electric charge. We have to study 3 basic properties of electric charge. First one, additivity of charge. What do you mean by additivity of charge? If a system contains n number of charges, a body contains n number of charges, then the charge on the system is the sum of all the charges. For example, a body contains different charges. One is Q1, Q2, Q3, Q4, etc., Qn. So what is the total charge of the system or total charge of the body? The total charge of the body is the sum of all the charges. The total charge of this body is the sum of all charges, that can be written as Q1, Q2, Q3 plus etc. plus Qn. If there are n number of charges, the total charge on the body can be taken as Q1 plus Q2 plus Q3 plus etc. plus Qn. Then one more point is in case of negative charges, sign of the charge is also considered. In case of negative charges, sign of the charge is also conserved. considered. Okay. So what is that? Listen, this is a body or system of charges. Then here it is 1 microcoulomb. Here it is minus 2 microcoulomb. Another charge 3 microcoulomb and another charge 4 microcoulomb. So what is the total charge of the body? We know that it is the sum of all charges, and also it is mentioned that the negative charge should be considered. The sign of the charge should be considered. So we can write the charge Q is equal to Q1. What is Q1? That is 1 microcoulomb plus. What is Q2? That is minus 2. You have to consider that sign. That is minus 2 microcoulomb plus 3 microcoulomb. 3 microcoulomb plus 4 microcoulomb. So what is the total charge? The total charge will be equal to 1 plus minus 2 minus 1 minus 1 plus 3, that is 2. 2 plus 4 is equal to 6 microcoulomb. So that is equal to 6 microcoulomb. So what is that? If a system contains n number of charges, the total charge of the system is the sum of all the charges. Okay. And also you have to consider the sign of the charge. If it is negative, you have to consider the sign of the charge. Okay. So here is one example for that. Next, which is the next property? The first property, that is the additivity of charges. So what is next? The next property is charge is conserved. We know that. What do you mean by conservation of charge? Charge can neither be created nor be destroyed. That is conservation of charge. But it can transfer from one body to another. Charge is neither be created nor be destroyed, but it can transfer from one body to another. And also there is in certain process, we know that in a process charge can be created by nature. Okay, charge can be created by nature. How? Changing of neutron into proton and electron. This is one process. Changing of neutron into proton and electron. So changing of neutron into proton and electron. Changing of neutron into proton and electron. Okay. Listen, what is the charge of neutron? That is no charge, neutral. What is the charge of proton? It is positive. What is the charge of electron? It is negative. So listen, what is the total charge before breaking? That is 0, no charge. What is the charge after creation of these charges? That is plus minus. Both are same, plus minus, it will become 0. So that means that changing of neutron into proton and electron, but total charge before and after the creation is same. So listen, the charge of neutron is 0. Same way, what is the charge of proton? That is positive, and the charge of electron is negative. But what is the total charge? Total charge will be equal to 0. That means the charge is conserved. In this case also the charge is conserved. So what is next? So we have discussed the two properties. One is additive property of charge, and second one it is charge is conserved. So what is next? That is quantization of charge. What do you mean by quantization of charge? The quantization of charge explains that the charge of a body always exists as integral multiples of E. So what is that? Integral multiples of E. So what is E? E is the charge of electron. What is that? Charge of electron or charge of proton. So E is the charge of electron. So the charge of a body always exists as integral multiples of E. What is that integral multiples? That means that is n is equal to 1, 2, 3, etc. So the charge of a body always exists as E, 2E, 3E, or we can give it as plus or minus, minus E, minus 2E, like this. E by 2 charge does not exist. Why? Because it is not integral multiple of E. Here the n is 1 by 2. It does not exist because n must be 1, 2, 3, etc. That means the charge of a body always exists as integral multiples of E. 3E by 2. The charge 3E by 2 does not exist. Why? Because the value of n here it is 3 by 2. It is not an integral multiple. Integral multiple means it must be 1, 2 multiples of 1, 2, 3, etc. So, charge present on a body can be assumed as integral multiples of the basic charge E. So, what is the value of E? What is the value of E? The value of E is given by E is equal to 1.6 into 10 raised to minus 19 Coulomb. So, what is the value of E? The value of E is equal to 1.6 into 10 raised to minus 19 Coulomb. Then it exists as integral multiples of the basic charge E. Then charge can be decreased or increased only in the step of E. That means increased by E, 2E, 3E, 4E, etc. or decreased by E, 2E, 3E, 4E, etc. So, it always exists as integral multiples of E. So, these are the three properties of electric charge. One is additive property, second one is charge is conserved, and third one it is a quantization of charge. Let us discuss some questions from this part. A body can be negatively charged by. How a body is negatively charged? By gaining electrons, a body can be negatively charged. So, first option, giving excess of electrons to it. Second one, removing some electrons from it, giving some electrons to it, removing some neutrons from it. So, which is the correct answer? It is the easy one. Giving excess of electrons to it. If we give excess of electrons to it, to that body will get negative charge. Okay, so the correct option is giving excess of electrons to it. So, what is next? Another question, listen. Two insulated charged copper spheres A and B of identical size have charges QA and QB respectively. A third sphere C of the same size but uncharged is brought in contact with the first, then in contact with the second, finally removed from both. What are the new charges on A and B? This is a CBSE previous year question. So, listen, they are identical spheres. What is first step? What is the first step? A and B of identical size have charges QA and QB. So, charge on A it is QA and the charge on B it is QB. Okay. A third sphere C of the same size but uncharged is brought in contact with the first, which is the first sphere. Okay. That is third, this is A, B and C is Q is equal to 0. That is sphere C. So, when the first step it is these two bodies are touching, then what is the charge on A? When A touches with C, what is charge on A? The charge on A can be written as Q dash. Q dash is equal to, we know that QA plus QC by 2 because they are identical. We have already studied that. If they are identical, we can say that the new charge will be equal to QA plus QB by 2. So, here this is QA and QC. So, what is QA? That can be written as QA plus QC plus 0 by 2. So, what is the charge on A after touching? That is QA by 2. So, after touching the charge A, this sphere gains some charge. Okay. So, what is the charge on C? The charge on C is equal to QA plus 0 by 2. That is QA plus 0 by 2. So, it will get QA by 2 charge. So, when these two spheres are touched together, then charge is transferred to C. So, it also get a QA by 2. So, it is not over. What is the next? A third sphere C of the same size but uncharged is brought in contact with the first and then in contact with the second. So what is that? Then in contact with the second. Okay, after touching A, the C is touched with body B. Then that can be written as touching C with B. Touching C with B. So what is the charge on the first body? Sorry, charge on the second body, that is QB dash is equal to, that is QB. What is that charge on B? Plus what is charge on C after touching this? That is Q A by 2 divided by 2, that is QB dash charge on the body 2 is equal to, what is that, 2QB plus 2QB plus QA by 2, it will become 4. So that is 2QB plus QA divided by 4. That is the charge on the second body. So what is the question? Uncharged brought in contact the first and then in contact with the second and finally removed from both. What are the new charges on A and B? The new charge on A, that is given by QA by 2, charge on A. So after touching that C with B, the B will get 2QB plus QA by 4 charge. Okay, so we have another question. How many electrons must be removed from an electrically neutral metal plate to give it a positive charge of 1 into 10 raised to minus 7 Coulomb? So have a positive charge of 1 into 10 raised to minus 7 Coulomb. So what is the value of Q? Q is equal to 1 into 10 raised to minus 7 Coulomb. Okay, then you have to calculate the number of electrons. Okay, that is Q is equal to Ne. What is the value of N? N is equal to Q divided by E. What is that? N is equal to Q divided by E. So what is Q? That is 1 into 10 raised to minus 7 divided by 1.6 into 10 raised to minus 19. That's equal to 1 by 1.6 or 10 by 1.6, that can be written as 6.25 into, here it is 10 raised to 12, then it is equal to 10 raised to 11. So that is equal to 6.25 into 10 raised to 11 electrons are transferred to get a charge of 1 into 10 raised to minus 7 Coulomb. So what is the answer? That is 6.27 into 10 raised to 11 electrons. Two metallic spheres A and B kept on insulating stand are in contact with each other. A positively charged rod P is brought near the sphere A as shown in the figure. The two spheres are separated from each other and the rod P is removed. What will be the nature of the charge on the sphere A and B? So it's a previous year question, CBSE 2019 question. Okay, we have already discussed about it. When we bring this positive charge to here, this left side will acquire negative charge and this side will get a positive charge. Then after removing this, the first body, the body A acquires negative charge and the body B acquires positive charge. So the body A acquires negative charge and the body B acquires positive charge. So what is next question? A metal sphere is kept on an insulating stand. A negatively charged rod is brought in near to it. Then the sphere is earthed as shown. On removing the earthing and taking the negatively charged rod away, what will be the nature of charge on the sphere? So listen, when this negatively charged body bring near to this sphere, what happens? The positive charges in the sphere moves to this side and negative charges will move to this side. This side is grounded. Then what happens? The charges flows to the ground. Then after removing this negative charge, this body will get positive charge. This positive charge is distributed on the body. When we place this near to this, the positive charges will move to this side and negative charges move to this side. Then what happens? This side is earthed, so this grounded, so that the electrons will flow, the charges will flow to the ground. Then what happens? The positive charge exists there. When we remove this charged rod, the body will get positive charge. Okay, here is another question. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 Coulomb. Estimate the number of electrons transferred. Okay, so electrons are transferred from wool to polythene because the polythene gets negative charge. That means the polythene piece gains electrons and the wool loses electrons. So we can write the charge on the body is equal to 3 into 10 raised to minus 7 Coulomb. So you have to calculate the number of electrons transferred. We know that charge always exists as integral multiples of E. So what is N? What is number of electrons? That is given by Q by E. So what is the value of Q? Q is equal to 3 into 10 raised to minus 7 divided by E is given by 1.6 into 10 raised to minus 19. So what is 3 by 1.6? That is equal to 1.875 into 10 raised to 12 electrons. So to get a charge of 3 into 10 raised to minus 7 Coulomb, 1.87 into 10 raised to 12 electrons are transferred from wool to polythene, so that the polythene will get the negative charge and wool will get positive charge. So this is the answer to the first question. So what is next? Answer second question. Is there a transfer of mass from wool to polythene? So electrons are transferred from wool to polythene. So electrons are transferred from wool to polythene. How many electrons? 1.875 into 10 raised to 12 electrons are transferred from wool to polythene. Then we know that electrons have mass, so that a mass is transferred from wool to polythene. So but electrons has very small mass, that is equal to 9.1 into 10 raised to minus 31 kilogram. So a small mass is transferred from wool to polythene because electrons are transferred from wool to polythene. So we can calculate mass transferred. How we calculate the value of mass transferred? That is equal to number of electrons transferred, that is 1.875 into 10 raised to 12 into what is the mass of one electron, that is 9.1 into 10 raised to minus 31 kilogram. Okay, so how much mass is transferred from wool to polythene? That is equal to 1.7 into 10 raised to minus 18 kilogram. So how much is transferred? 1.7 into 10 raised to minus 18 kilogram mass is transferred from wool to polythene. So it's a very minute mass. Okay, so but a mass is transferred because electron has some mass. Okay.